Hi guys, welcome to this set of videos. These videos are going to follow along with the notes that come out of your textbook from Chapter 8, Section 2. Now here in Chapter 8, we've already discussed the fact that we're going to be talking about rational expressions and rational functions. In just a section or two here, we're going to begin to take a look at rational functions and how we can go about graphing those guys. But for right now, in section 1 of this chapter, we took a look at simplifying rational expressions, and then we began to take a look at how do you multiply and divide those rational expressions. Well, now here in Chapter 8 and Section 2, we're going to begin to look at what do you do when I want you to add or subtract those rational expressions. Now, just a quick, what we've been doing is we've been kind of making parallels between what we did in arithmetic back in middle school with fractions, right? And now what we're doing here in Algebra 2 with rational expressions. You'll remember to add or subtract a fraction back in middle school, you needed to find a common denominator. In fact, we looked for what we call the LCD, the least common denominator, which you can get by finding the LCM, the least common multiple. Again, we'll get to all of that here in just a second, but before we start taking a look at how you add and subtract rational expressions, let's get a couple of objectives, something to kind of help us focus as we make our way through this set of notes. So here's the things you should be able to do by the time we get to the end of this set of videos and the end of these notes. First, you'll need to be able to determine the LCM of both monomials and polynomials. I know here I only have polynomials, but really you need to be able, a monomial is a type of polynomial, right? So you need to be able to determine the LCM of polynomials. Again, LCM means least common multiple, and the reason we need least common multiples is because to add and subtract rational expressions, you need a common denominator, and the LCM is going to be our common denominator. So we're going to work on that first. Then once we get good at finding LCMs, we'll do exactly what I said. We will add and subtract rational expressions. Add and subtract rational expressions. So just as in Chapter 8, Section 1, hopefully what you guys will see is some parallels, right, between what we did in arithmetic in middle school with fractions and what we're going to do here in Chapter 8 of Algebra 2 with rational expressions. Now obviously what we're going to do here is quite a bit more complicated and a little trickier, but it kind of matches up with what you guys have already learned about fractions. So let's go ahead and jump right into this. All right, a little bit of terminology. Again, nothing new here. Least common denominator. Now, the least common denominator, which we will call the LCD, is the least common multiple, the LCM, of the denominators of the fractions that are being added or subtracted. So, the goal in this section, Chapter 8, Section 2, is to add and subtract rational expressions. But in order to add and subtract fractions, you must have a common denominator. And we're going to find that common denominator by finding the LCM and then making our common denominator whatever that LCM is. But to get us started doing that, we need to practice finding those least common multiples. So again, let's just review a little bit about what you guys would have done back in arithmetic, way back in middle school, by taking a look at factoring, finding LCMs. Now, let me say this about the LCM. Real quick note. The LCM contains each factor the greatest number of times that it appears as a factor. So the LCM contains each factor the greatest number of times it appears as a factor. Essentially, here's what that means. That just simply means if the factor shows up more than once, you're going to keep whichever one has the highest power. So you're going to be looking for the largest power. Sometimes that largest power will be a 1, but sometimes it'll be something bigger than that. Okay, so here we go. Let's just jump into this. Again, we're reviewing what you guys would have done back in arithmetic when we asked you to factor. Now, I am going to, in this chapter and section, I'm going to do linear factorization, right? So all of these guys here are what's known as a linear factorization. Oh, sorry, I had to squeeze there. Linear factorization, but you could just as easily do factor trees, and I'll show you that right over here. You guys may remember factor trees. Okay, so here we go. We want to find the LCM, the least common multiple of 6 and 4. Well, if you guys were doing factor trees in middle school, right, you would take the 6 and you write, all right, I can factor the 6 into a 2 and a 3, right? 2 and 3. Now, that means that 6 is equal to 2 times 3. Right? Which is exactly what I have. 6 is equal to 2 times 3. So 6 can be factored into 2 and 3. 4 can be factored into a 2 times a 2. So 4 is equal to 2 times 2, or 2 squared, right? So the factor tree says 4 is 2 times 2, which 2 times 2 is simply a 2 squared, which is exactly what I have here. 4 is equal to 2 times 2, which is a 2 squared. Now the LCM contains each factor the greatest number of times that it appears. So in my factorization, right, I have a 3. It only shows up one time, so I have to keep it, right? That one time it shows up, it's a 3 to the first, so there's my 3 to the first. But 2 shows up more than once. Here I have a 2 to the first, here I have a 2 squared. Well, we keep each factor the greatest number of times it appears. That means you keep the one with the largest power. So we keep the 2 squared. So 2 squared times 3 is my LCM. Well, 2 squared is 4. 4 times 3 is 12. And so the least common multiple of 6 and 4 is 12, right? Let's just, again, I got another one here for you. Again, we're just quickly reviewing middle school. Again, I'm going to do linear factorizations. You could just as easily do factor trees if you wanted to, but linear factorizations, 18, 6, and 3. But the 6 will split into a 2 and a 3. So 6 is 2 times 3 times 3. I have 2 3s, so it's going to be a 3 squared. All right, so that's my factorization. 3. Well, 3 is prime. It's just 1 and 3, so 1 and 3. Now, I keep each factor the greatest number of times that it appears, right? So I take a look at my factorizations, and I have a 1. 1 only shows up one time, so I keep it. The 2. Well, 2 only shows up one time, so I keep just the 2. But 3 shows up more than once. Here it's a 3 to the first. Here it's a 3 squared. You keep whichever one is the greatest number of time it appears, whichever one has the largest exponent. That is the 3 squared. So my LCM is 1 times 2 times a 3 squared. Well, 3 squared is 9. 9 times 2 is 18. 18 times 1 is 18. So the LCM of 18 and 3 is 18. All right? What we're going to do then, if you just flip over here real quick to the next page of the notes, right? Well, how does that apply to what we're going to do here in Algebra 2? Well, what we're going to do is we're going to be dealing with variables, right? Because it's algebra. So the simplest form of this is going to be a monomial. We'll get to the more complicated polynomials like binomials and trinomials and so forth in just a second. But let's start simple, right? LCM of a monomial, something that contains variables. Well, we need to do the exact same thing. We need to find the LCM of 2 or more monomials by factoring each of the monomials. And again, keep in mind what I mentioned before. The LCM contains each factor the greatest number of times it appears. That means you keep whichever one's got the largest power. So I worked through one of these for you. We'll do a couple on our own here in just a second. 15a squared, bc cubed. Well, 15 factors into 3 times 5. 3 times 5. Guys, when it comes to the variables, do not need to factor the variables. Just leave the variables as they appear. A squared, b, c cubed, c cubed. You only need to factor the constants. You don't have to factor the variables in the monomial. So 15 is a 3 and a 5. 16. Well, 16 is 4 times 4. But the 4s can be broken down into 2 times 2 and 2 times 2. Well, that's 4 2s. That's a 2 to the 4th, right? So I skipped a couple of steps here, but you should be okay with this, right? 16 is a 2 to the 4th power. B to the 5th, c squared. Well, what about 20? Well, 20 is a 4 times a 5. But the 4 can be factored into a 2 times a 2, right? So that's a 2 squared times 5. That's its factorization. 2 and 5 are both prime. I can't factor any further than that. Leave the a cubed and the c to the 6th. Now I go through and I find all of the factors that appear, but keep the ones that appear the greatest number of times. All right, well, 3 only shows up once. It shows up right there, so I keep the 3. There it is. 5 shows up twice, but in both cases, it's a 5 to the 1st. So it doesn't matter which one you pick. Either of them is fine. There's my 5. 2 shows up twice, 2 to the 4th and 2 to the 2nd, but we keep the greatest number, the largest power, so 2 to the 4th. So there's my 2 to the 4th. You do the exact same thing for the variables. A shows up twice, a squared, a cubed. You keep the bigger one, a cubed. B shows up twice, b to the 1st, b to the 5th. You keep the bigger one. And c shows up all 3 times, c to the 3rd, c squared, c to the 6th. You keep the biggest one. So that's where the 2 to the 4th, the 3 to the 5, the a cubed, the b to the 5th, and the c to the 6th come from. I factored them. I keep each factor the greatest number of times it appears. And multiply all that stuff together. 2 times 4 is 16. 16 times 3 times 5. Again, feel free to use a calculator. 240, a cubed, b to the 5th, c to the 6th. That is my LCM. All right, now that we've gone through a couple that I've already done for you, just to kind of show you how the factorization works, let's do one from scratch. So here we go. 6xy. Well, I'm going to do my linear factorization. So 6xy is going to be 2 times 3 times x times y. 15x squared. Well, 15 is 3 times 5. 3 and 5 are both prime, so I can't do any more than that. And I leave the x as a squared. Leave the variables as they appear. 9xy to the 4th. Well, 9 is 3 times 3. 3, of course, is prime, but there's 2 of them, so that'll be a 3 squared times x times y to the 4th. My LCM. Well, keep each factor the greatest number of times it appears. 2 only shows up once, so there it is. 3 shows up all 3 times. 3, 3, 3. I keep it the greatest number of times it appears. That's 3 squared. 5 only shows up once. X squared, that's the biggest one. Y to the 4th. So here we go. My LCM is 2 times, equals 2 times 3 squared times 5 times x squared times y to the 4th. Multiply all that stuff together. 3 squared is 9. 9 times 2 is 18. 18 times 5. I got a calculator real quick right here. I get 90. 90x squared y to the 4th. So my LCM is 90x squared y to the 4th. All right, guys, hopefully that makes sense. Head on over to the next page of the notes. We'll try another one together. I'll meet you there.